Good morning and good afternoon. Welcome to Omni and welcome to our inaugural webinar, the first of many to come. I'm Tara Kordiak, Director of Sales for Omni, and with me today is Chelsea Minton, our sales engineer up in snowy Boston. She'll be jumping in shortly to walk you through our product demonstration. A few housekeeping items to get us started. You will be on mute for the duration of the webinar, and this webinar is being recorded. If you're having technical issues or need immediate assistance, please type your issues into the chat window to Athena White's attention, and she'll help get you sorted out. If you have questions about our content, the product, the demonstration, or our organization, please use the hand raise symbol in your window, and we'll address your questions at the end of the session. Additionally, if you wish to contact us directly with questions outside of this webinar, we're happy to talk to you directly. My contact information will be up at the end of the webinar, and we'll address questions individually as best we can. We will have a short Q&A session at the end of this webinar. Firstly, let's get you acquainted with Omni a little bit. A little bit about Omni fundamentals here. Who are we? Why are we here? Why are we talking to you today? We've been incubating for about 4 years. We were established in May of 2014, and Omni is, at its core, an analytics company, founded on the belief that physically verifiable data, measurable data, combined with high-power analytics, produces valuable and actionable insights. Leveraging the power of geospatial information and derived intelligence from imagery, fusing that with other types of data, economic data, population data, financial information, environmental and weather data, mobile phone sensor data, the list goes on. And then applying science and math-based algorithms, you can access valuable insights, analyze those insights, and act on them. They're not just interesting, but they're actionable. Offering these analytics products as a cloud-based subscription enables clients to take advantage of cutting-edge technologies and computing power without having to invest large amounts of money and without having to expend extra resources. Here are a few examples of where we have impact. Omni creates solutions for users all across the board. The oil and gas community, examples include high consequence area analysis, pipeline encroachment analysis, asset tracking, asset tracking and location, integrity management, and even emergency response planning. We also have applications in the mining and exploration world, mine reclamation, mine site security monitoring, natural resources, which we're talking a little bit about today when we're talking about water conservation and budgeting, but we also talk about forestry applications, tree canopy analysis, sustainability initiatives, financial and economic development, agriculture as well, crop yield and prediction products, crop monitoring and field management, commodities tracking, and the list goes on. This is just a sampling. With the robust platform we have running behind the scenes that tap into analytics resources, engineering capabilities, and a plethora of data sources, we are building a digital landscape of the globe that can be tapped into in order to answer many complex, vitally important questions about our economy, our planet health, and our safety. But today, we'll be talking about water, and more specifically, the efforts around water conservation. The use case we're highlighting during this webinar today will show you how you can create a parcel water budget to aid in the identification of overusers or overconsumers of residential water, specifically around maintaining irrigated landscape, which has been proven to be the most detrimental to water supplies. While the service we'll be demonstrating today was born out of the 20 by 20 mandate requirement set forth by the state of California, and initially developed to support drought-affected districts, and in particular, a customer in Northern California, you will see the applicability of this service reaches far beyond California and even beyond states affected by drought. Anyone dealing with water usage issues can leverage the power of this product and service. Many non-drought affected areas also have overconsumers that need to be addressed. Today, many districts are spending quite a bit of money and time on efforts leading to water conservation. Omni-Earth's product delivers results you can act on at a fraction of the cost of what you're spending today and be less resource intensive. And although the use case we're showing you today is focused on residential parcels, as you'll see as Chelsea walks you through the demo, the application is easily transferable to commercial and industrial water use as well as agricultural use. We'll show you how you can start conserving water in your district, your region, or your state within a few short weeks, in some cases reducing water by 50%. Omni-Earth's application, and this product in particular, combines water usage data, satellite or aerial imagery, and parcel boundary information to put water usage and waste into context, helping resource managers and policymakers guide future use. So what exactly does this all mean? This service, this secure service, can, in an automated and scientifically validated fashion, show you on a map what each parcel in your district should be using against what each parcel is actually using, enabling you to quickly identify overusers and target your conservation efforts to have immediate impact, thus reducing water usage at a much lower cost. So how is this being done today? We've had a lot of conversations with water districts, and we've learned quite a bit about how things are being done today in terms of determining water budgets and actually targeting overusers. Many water districts have a need to develop baseline water budgets, or at the very least have a need to understand what their landscape looks like in terms of water usage potential across their community. Much of that work being done today to create that baseline or those water budgets is being done manually. Much time and expense, upwards to $5 a parcel or more in certain districts, is being spent to manually measure parcels, determine land cover, to ascertain how much irrigated surface a particular parcel maintains, and then to actually identify those overusers. This is a lot of money. This is expensive. It's error-prone, and not to mention time-consuming. Additionally, this isn't refreshed regularly. Some districts aren't even going this far and only enacting restrictions holistically across their district in order to affect water conservation. For example, don't water your lawn on certain days to minimize water use. And then fines are applied to those breaking the restriction, but that takes resources driving around and catching people in the act. Again, time-consuming and costly. What we're going to be showing you today reduces that cost quite a bit to sub-dollar, and also reduces your time in terms of saving water and saving money. So at Omni-Earth, we can't affect occurrences of drought, obviously, or consumer behavior. We work hard to deliver solutions to help you deal with the inevitable. Droughts can happen. People are going to overuse. For this specific use case within the water resource management product line, we have streamlined the entire process of creating that water budget for utilities across the country, therefore establishing baselines for districts on which resource managers can act. It's not about providing more data or selling another expensive software package. It's about providing smarter data, delivering actionable results. Using data you already have, you automatically analyze your service area and determine which users should be targeted in focused conservation efforts. More importantly, you see the results of all this analysis in a very easy-to-use, interactive set of dashboards. This allows you to see the parts of the data that matter the most to you. So fast, measurable results leading to better, faster decisions. You don't have to be a developer, you don't have to be an engineer, you don't have to be a GIS expert. You don't need to do any coding or number crunching. You just consume that information and act upon it. So now you can start targeting your conservation efforts around overconsumers quickly, reduce water usage in a more systematic and efficient way, and you're not spending a lot of money doing it. So again, as opposed to sending your troops out into the field to investigate every single parcel in your district to see what their land cover looks like and are they overusing, you can just further investigate those outliers. So it's a tipping and queuing mechanism so you can have a more targeted approach, which again, leading to saving time and money. are meeting compliance criteria in some cases, like in the state of California. It's very important to be meeting this criteria set forth in the mandate, and you're working towards water use conservation. Again, this is a cloud-based subscription. We're not requiring any software deployment or development or implementation. You have access to the information at a fraction of the cost of doing this manually or in another desktop software program. So that's all great. So how does it work? What does it look like? How does it actually help you? So at this point, I'm actually going to pass the mic, hopefully, over to Chelsea in Boston, and she's going to walk you through the product demonstration live. Chelsea?
Great, thanks Tara, and thanks everyone for being here today and listening in. We'll keep this short, but I'm hoping to use a few minutes here to dive into some more of the specifics on exactly how OmniEarth is providing districts with water baselines, water use targets, and these other sort of critical benchmarks that they require to drive conservation and to stay within bounds of the various government mandates that Tara's already touched upon. So today, you can do this with OmniEarth's rapid high-power analysis, and it virtually eliminates the time-intensive and cost-prohibitive process of determining water baselines that we're used to seeing. So my background is actually in geospatial sciences, so I am quite familiar with what it's like to sit around digitizing land parcels or leaving your desktop running for days to run some classification analysis or something in order to identify irrigable land. So we have done away with all of that. And what I'm showing now is a very basic graphic that shows the flow of information through our water resource management product. The concept is we connect relevant data, it churns through our analytics engine, and you get fast and reliable results. And remember, the product, as Tara has mentioned, is off the shelf, ready to go. So we're not talking about any development or implementation time. The concept is plug in and go. So first, we aggregate 3 data sets. Parcel data from your district, your existing water meter data if you have it. If you don't, that's fine. And satellite imagery of your area. We run custom analysis on this data to produce a land cover classification that helps us quantify how much water every parcel in your district should be using, and I'll speak more to that. Then you simply log in. You basically use our authenticated login system. You get into our dynamic cloud-based application, and it provides you with your results. So you get a water budget, you get all of your heavy consumers identified, your landscaped area water use by parcel, gross water use for your district, and a variety of other variables depending on your needs. And all of that, as Tara has mentioned, available in an intuitive and simple dashboard, so everything's easy to see and in one place. This series of visualizations that you get is made up of maps, grids, filters, and simple tools that you can use to take action right away. So as I mentioned, the first piece of the puzzle is identifying and plugging in the necessary data sources, right? So imagery, parcel, and water meter data. And none of this requires any coding. Our product is data and system agnostic, so we can synchronize with existing systems immediately. And if you don't have imagery or parcel data, that's something we work with all the time. We have close relationships with vendors across the industry, and we can absolutely help you acquire whatever you need, whether it's parcel data or satellite imagery to meet certain specifications. That's right within our wheelhouse. Now, the most technical part of our product involves the imagery analysis, so I'm going to touch on that for a few minutes here. And I want to make it clear that this analysis is done behind the scenes in an analytics engine. So your imagery is processed through a series of customized algorithms to determine the land cover for your entire district. So we start with what you can see, this image on the left. We start with that, and we produce a layer that looks like this image on the right, where the surface type for every pixel in the image has been identified. And we then know quantifiably how much of the land is covered by man-made structures, how much is covered by vegetation, by trees, swimming pools, so on. And the product does this by using a raster imagery analysis technique called classification. Some of you may be familiar with it, but our product employs custom OmniEarth classification algorithms that have been built and tweaked and proven out specifically for use in drought-prone areas. And Tara's mentioned that this product does have applicability to water conservation efforts across, so drought states or non-drought states, but I'm specifically discussing this drought use case, so I'm going to focus on those set of analytics, but I just don't want folks to think that there isn't applicability elsewhere. So our analysis results, we're now able to guarantee the accuracy of those results to somewhere between 90 and 95%, which is pretty impressive. And we've achieved that level of success by extensively training the data. And that happens through an iterative process called machine learning. It's used in tons of different industries across the board in technology, but in essence, what we use machine learning for is during this process of pixel identification, we essentially say to the computer, you know, this blue blob here is a swimming pool, and this blue blob is also a swimming pool, and ultimately the algorithms get smarter and smarter at identifying those swimming pools all by themselves, and the same goes for all of the other land cover class types. So we used that machine learning process during our analytics development to limit inaccuracies and guarantee precision. And the nice thing is that even today, the results continue to improve with each iteration. So once we have this land cover classification layer, you know, what do we do next? Well, the results that we get from that first set of analysis are analyzed against a standard government vegetation index. So in this case, we used NDVI, which some folks may be familiar with as a very standard vegetation health index, and also used evapotranspiration rates that essentially tell us how much water each vegetation type needs in order to be healthy based on how much land it covers. So, you know, crabgrass requires X amount of water per square foot, and so on and so forth down the line. And the result is a quantifiable water budget that shows exactly how much water each parcel needs based on its land cover. And similar analysis results can be run that show landscaped area water use targets for each parcel, gross water budgets, and other benchmarks that are required for particular districts in particular states. When you use the OmniEarth Water Resource Management product, you don't have to worry at all about all that sort of heavy lifting stuff. That's all behind you. Instead, all of these things that I just covered are calculated automatically. So when you log into the product, you see results. And you can automatically, and you see this example of the product actually on your screen right now. And it shows the newly derived water budget. So we've got that in a grid right here. And it also is going to show land cover, which is a layer that's turned off at the moment. But more importantly, even than those results, you'll also notice, and when I log into the system, you'll see it live, it automatically ingests your other relevant data sources. So in this case, we pulled in the parcels, which are a geospatial layer, and that may come from a geospatial source. But we also are able to pull in your existing water meter data if you have it, right? So that's a business or relational data source that's also able to be ingested so that you see everything side by side. These numbers offer true measurable results, and they allow for the immediate targeting of heavy users, right? And this is kind of the gold standard, because even if you know how much water a parcel is using, if you are collecting water meter data, you still need to have a baseline to know if they're truly using too much. So, you know, take for example, everybody has a neighbor, let's call him Bob Smith, right? And everybody has this guy on their street who's constantly watering his lawn, even during restricted hours. You know, we all know that person. But in the water budget, you can see exactly how much water Bob should be using, and with actual water meter data right below it, we can compare his actual usage to his ideal usage from that budget. And with that information, the neighbor is easy to identify as an overuser, especially when compared to other lots that are the same size. And in fact, your OmniEarth product will even do that identification for you. So the product serves you a visual layer where the heaviest users are identified in red parcels. So you can see that on your screen right now. And there's a spectrum of colors, so the most efficient users are blue, the heaviest over consumers are red, and then obviously there are folks in between. So again, when you log into your system, these results are immediately accessible and identifiable. But rather than talk about it and just show you slides, I'm going to go ahead and log right into the product live and show everybody kind of what the end user experience is like. So as we've mentioned, this is a cloud-based product, which means you will see rapid processing and display speeds. And as a quick aside, what you just saw is that the product does require an authenticated login. And while I'm not going to really cover security in depth, I can certainly answer security-based questions if folks have those during the Q&A. But I can offer, we regularly work with different industries and organizations that have incredibly high security standards throughout, oil and gas, energy, government agencies, and they have very rigorous security demands, and we have passed all of the in-depth security audits without issue. So I wanted to mention that. And then beyond external data security, I also want folks to be aware that once you're in the product, users who each have their own individual login can only see what they are allowed to see by their administrator. So it is possible for administrators to limit or decide and easily kind of configure who has access to what data within the product. So now once you open your product screen, you have access to a series of dashboards, one of which is open in front of us. Each one consists of maps, grids, graphs, or detailed views in each of these components on the screen. In this instance, we're obviously looking at a map component first. Our map components use the familiar Google base map, and we love it for it's indisputable in terms of speed and accuracy. And also, it's really quite familiar, and across the board, organizations are finding that it makes for fast adoption of the product because folks are already used to using the Google Maps. All of the components in our product are dynamic. So in the map component, I obviously have the standard tools like zoom and search, but I can also toggle layers on and off, and you may have just seen a flash as I zoomed in of my land cover classification layer, which is hiding underneath my imagery here. And I have some other neat little features, like I can switch into street view if I want to zoom in and take a closer look at a particular parcel. I can do that right from within the product. Again, hitting on Tara's point where maybe I don't need to spend so many manual man hours out in the field and logging walks through the neighborhood because I can do a little preliminary scoping right here. So in this particular map, I've ingested parcel data, imagery, and land cover classification results. I want to make the point that all of these are from different sources but coalescing into this one simple presentation format, and that's really critical to what we do, right? Providing easily accessible and intuitive information. As I click around my map, users will notice, and I'm going to go ahead and select some of these parcels here, users will notice that there's automatic synchronization between information in the grids and information in the map, as well as the ability to ask more complex questions. So you're able to use things like customizable filters, which you see up here. The filter tools allow for standard querying of any data, so you can create those based on any of the attributes you have in your data source. You can save them for later use. And we also have basic standard sorting, and just very easy to kind of get around and make use of the data on your screen. Furthermore, components also allow us to display nested or parent-child relationships, just to borrow some database lingo there. These parent-child relationships essentially mean that we get an easy way of seeing a whole bunch of information that's related to a single data record. So in this case, data record is the individual parcel that I can scroll for and find it, and these grids automatically provide a response with all of the related information for that particular parcel. And that's, so that's something that we do quite well and makes it much easier than dealing with tree structures or other things that that systems have come up with to try to see this kind of nested ownership-based relationship. So we'll make it quite easy to scroll through and see all that related data. Now, the product comes with a standard set of dashboards, and each user gets this drop-down menu here of the dashboards that they have access to. And I want to, this is a sort of a quick aside, but if you should want additional dashboards, again, there's no coding required here. And you can simply come in and choose to create a new dashboard and create an existing template, or you can obviously ask folks at OmniEarth to do this and provide you with maybe a whole other series of dashboards. You simply select your layout, and then with an easy kind of click-through wizard, you decide whether you want it to be a map, grid, and what data you want to see in that particular component. And we're talking, 10 to 15 minutes to create a new dashboard. So I just wanted to emphasize that the product is off the shelf and ready to go, but it also does have the flexibility to accommodate project expansion. So this is just an example of the same data in sort of a simpler view with a grid that will just respond as I click around and provide me only the land cover by parcel of that particular parcel that I click on. Okay. So the product has some other advanced capabilities I'm not going to cover in detail today, such as automatic rule-based notifications, easy workflows that can track changes or conservation outreach efforts all in the system. Again, no coding required. And if you have more questions about that functionality, I'm happy to discuss afterwards today. Just kind of wanted to focus on this baseline analysis and providing the water baselining and water targeting results. So far we've found that this type of visualization provides a lot of context and meaning to data that was otherwise difficult to parse through. I mean, our visualizations are created with multiple audiences in mind, from the technical sort of expert to the field operative to the management team. So I should add that these dashboards can be accessed on any secure browser or through our mobile application. I guess before I turn it back over to Tara, the main thing I just want people to take away about this product is that it completes some very high-powered analytics faster, and I can say confidently with more accuracy than we've seen anyone do in-house. And it provides you with this quantifiable, actionable set of results in a really simple and intuitive cloud-based interface. So with that, if you have any further technical questions about the product itself, please submit them. I'm happy to answer during Q&A, but I'm going to pass it back over to Tara to wrap things up.
Great, thanks, Chelsea. And we have had a few questions submitted that are great, and we're definitely going to address those in a couple moments. I'm just going to wrap up here. So Chelsea just walked you through a demonstration of the water resource management product, kind of flavored towards residential water baselining and targeting of outliers. She showed you how you can access an automatically generated land classification layer, combine that with water parcel information and water meter data to quickly create that water budget baseline for your district or your region of interest. You can then quickly identify out. Chelsea also talked about the different data sources relied upon to create this particular product. I wanted to take just a moment here to mention that this product can come in different flavors. The data inputs can be variable. So as Chelsea mentioned, if you don't have water meter data, we can work with other data sources you may have available. If you don't have access to aerial or satellite imagery, we can work with you to access the information needed to do the land classification. We can adjust our inputs to create the product that suits your needs best. So we're talking about residential here, but we also have applicability into commercial, industrial water use and agricultural as well. So it's a matter of working with those customers or those users to access the information, the data they have on hand to do similar types of analysis. So the iteration that you saw today that Chelsea just walked you through is really an example. It's a good one for sure, and built on true requirements put forth by a particular customer, but it's a guideline to show you what this application can do. So some main takeaways from today. We saw the slide earlier in the presentation, but I wanted to wrap up with it as well because it really is the crux of what we're talking about. We're talking about accessing and analyzing and acting, right? Without spending a fortune, which is key, without expending too much effort and resources. You subscribe and integrate existing data. You can use it anywhere, anytime. Chelsea mentioned mobile as well. You can analyze and get the results that are powerful, repeatable, fast, and true. And then you can act. Anyone can act. This becomes part of your workflow, giving you actionable information. So in quick, just summary about the service, we're really about, again, providing actionable results. Not more data. You have plenty of data, but valuable insights you can do something with. And in this particular case, that something is reducing water consumption, saving money, and potentially complying with regulations as well. So we take on that technical burden. Your data is aggregated, taking advantage of the hard work and money you put into your GIS system. You're not licensing new software. You're not having to get IT to support you or configure something for you. You're subscribing to a service. You're getting access to actionable results. You can share those results up and down the chain and even out to consumers if you wish. The greatest benefit of all here is you will recognize success. When you can quickly visualize the outliers or those overusers in this case, you're better served to act on target initiatives for water conservation. You can prove your work. You can do this as frequently as you need to as well as new data is coming in. As I mentioned earlier, when you're talking about doing a manual process, the refresh rate of that is pretty infrequent. With this process and this product, that refresh rate can be as frequent as you need it to be based on how frequent your data is coming in. So you'll consistently and constantly have a picture of your water usage in your district, and you can act on it. So if you'd like to learn more about this service, about this product, discuss pricing, get a proposal about our service, you can reach out to me directly. Here's my contact information. I'm also happy to address questions and insights you might have in general. We're always eager to learn about this process. This is a dynamic process. We're inputting new thoughts and features on a regular basis, so any comments and insights from the field are always useful. And now we're going to take some questions. We've got a few questions submitted we'll address. If we don't get to yours for the sake of time, you can send me an email directly and I'll get back to you very quickly. So with that, I'm going to move on to the questions. We have a question from the audience. Do you need customers' permission to access the data? So in short, yes, we do need permission. We're working with customers to access their data. We can get access to parcel data. We can acquire satellite aerial imagery on behalf of the customer. But for the data a customer actually owns, like water meter data, we do work with our customer very closely to get access to that information. And as Chelsea mentioned, it's a secure system. So we have authenticated logins and processes in place to keep that data secure when we access it. But we're working really closely with customers to get access to the data that we need. Chelsea, did you want to add anything to that?
No, I think that's a great summary.
Okay. And then another question was that this looks great for residential use, but what about commercial and agricultural applicability? So as I mentioned a couple times throughout, this iteration, this version of the product is focused on residential parcel information, but this does extend to commercial and industrial use as well as agricultural. It's dependent on the customer or client requirements and data sources that we have access to. So this methodology and the algorithms and the capability behind the scenes is applicable across commercial, industrial, or agriculture. So we can certainly, if you have a particular question, a particular need, use case, we're happy to discuss that on a one-on-one basis. You can reach out to me directly, and we can talk about that. But for sure, we're showing a version here today for a particular residential district, but the capability extends far beyond just residential.
Sorry, Tara. No, I would just add to that. That's absolutely right on point. And I would just add that we're actually, we are working extensively to build our agriculture product line as we speak. And I've gotten to see some of the indices that we're using. Obviously this is a basic land cover classification for residential, but the work that we're doing in ag is much more in depth in terms of looking at soil data, weather data, integrating not just NDVI, but upwards of 10, 15 more indices. So we actually have an entire demo of an ag product that, so if anyone's interested in seeing the ag product demo, we can absolutely do that as well.
Right, exactly. So one other question just came in. How does the satellite imagery differentiate between tree canopies covering turf grass versus canopies covering dirt or stone, etc.? Chelsea, this is a good one for you.
Yeah, this is a question that we hear a lot, and ultimately, so obviously the baseline of what the land cover classification does is determine surface. Right, so satellites aren't great at looking through objects on the ground. However, the tree canopy question is an important one, because if someone has an extensive amount of grass or unirrigated land underneath the tree canopy, then we need to be able to quantify that. So without getting into the real nitty-gritty here, we're working on developing algorithms that will essentially try to come up with the most accurate predictor of what would be underneath that tree based on what we see around it. And given the success that we're seeing with all of our other algorithms and all of our IP in that area, I would expect some very positive and accurate results there as well. But yeah, if anyone wants more information on that, we can put you in touch with our data scientists that are working on that process.
Thanks, Chelsea. So another question, is this useful where there are no water meters?
Yes, maybe more useful.
Okay.
It's great to have water meter data because you can do this automatic comparison, but where you don't have water meters, you're sort of at even more of a loss because you don't even know what actual usage might be. So this is one step in the right direction in terms of, wow, you come out of this with a quantifiable set of budgets and baselines that you didn't have before, regardless of whether you've got actual usage per parcel or not. And from there, we're getting into all of the questions about predictive analytics, which is, as Tara said, we're an analytics company. And so we do expect to be working on analytics to be able to predict usage. So pretty soon we expect it won't matter as much if we have actual water meter data as it will to have that budget and be able to predict usage based on the budget. So that's going to be something that is going to be infinitely more valuable whether you have water meter data or not.
Hey, Chelsea, our Director of Products just chimed in with an additional comment on the satellite imagery piece, which we actually touched on before we started the webinar around seasonality of imagery. So back to the satellite imagery question, being able to leverage different seasons, collections of imagery, we're able to actually see under tree canopy, right? So leaf off in certain regions of the world, obviously, we're able to leverage different kind of vintages and versioning of aerial and satellite imagery as well.
Yep, great point.
Yeah, so thanks, Alistair. I know you're listening. So we have time for one more question for the sake of keeping everybody somewhat on track today. So I'm going to pick a good one here. Oh, sorry, one more question came from does it have to be satellite imagery? The answer is no. It can be aerial or satellite. Resolution is somewhat important here, but in terms of, commercially available imagery, we can use aerial or satellite-based imagery. So one last question. What is the advantage of using this cloud-based application for this type of analysis? So I think we touched on it a few times here, and I'll let Chelsea chime in, but we mentioned, not having to deliver you a software package, right? You don't have to implement something. You don't have to learn code. You don't have to be a GIS expert. You're leveraging the power of the cloud, always on, accessible, and it's something that is pervasive now, right? You can utilize it across multiple platforms, mobile, desktop. But it really comes down to that point of not having to implement something new on your side, right, and getting IT buy-off and support. But we're also able to tap in and leverage the power of cloud computing. And I'll let Chelsea wrap that question up if you have anything else to add, Chelsea.
Yeah, I mean, just what you've said, Tara. It allows us to be infinitely more flexible and faster. You know, instead of when you build something in house, being dependent on your own servers, we're able to very quickly with a cloud-based platform plug into you know, the fastest servers, the best analytics engines out there, the best base maps, we're able to take advantage of all the great technologies coming out there. We're wildly adaptable, so if something better and faster comes out in 2 years, we can use it, and you know, we're able to harness all of that power when we're running these analytics behind the scenes, and that's why you can essentially just push your data and have the results, because we're talking about the speed of resources that are cloud-based. So speed is my big thing, and it works for all of us. Yep.
Thanks, Chelsea. And to that point, there's actually some great questions that came out of this today. If anybody who asked those questions wants to explore further the answers and how it's applicable to your use case or your concerns or issues, please reach out to me directly. We're happy to set up a time separately to chat with you. So with that, we're going to wrap the Q&A and wrap the webinar. Thank you for participating today. This webinar will be available on our website as well. We've recorded it, so you can share with any of your colleagues that couldn't be with us today, or you can rewatch it at your leisure if you so choose.